Hello everyone, welcome to Mechanical Engineering online classes, MIOC. This is Shravani Sriramoju. So let us see how to solve a problem on dynamic force analysis, also called inertia force analysis, using analytical method. Here the question is that a single cylinder horizontal steam engine has a stroke of length 0.84 meter and the connecting rod is of length 2 meter long. The mass of reciprocating parts is 500 kg. Reciprocating part is piston and that of the connecting rod is 250 kg. The center of gravity of the connecting rod is 0.9 meter from the crank pin and the moment of inertia about an axis through center of gravity and perpendicular to the plane of motion is 110 kg meter square. So for an engine speed of 100 rpm and a crank position of 45 degree from IDC, determine the torque on the crankshaft due to inertia of the moving parts by analytical method. So let us write the given data to this. So all the given data is noted down. This capital L is the length of the stroke. So from the given data, since n is given, we can find omega from n. We know that omega is equal to 2 pi n by 60. So substituting n here, we can get omega. Then we get omega as 10.47 radian per second. From the horizontal engine mechanism, we know that at the first extreme point of the crank, this crank will be here. So let this be IDC. And after 180 degrees, the crank will be somewhere here. This is ODC. So the piston, as the crank rotates, will be moving on the line of stroke for a distance of IDC to ODC. Since O is center, IDC to O and O to ODC is equal. This is the radius. So the length of stroke is IDC to ODC, which is nothing but in terms of the crank length, it will be R plus R, that is L is equal to 2R. So in the given question, L is given to us. So from this we have to find the R. Given stroke length L is equal to 0.84. We know that L is equal to 2R. So R will be equal to L by 2, that is 0.84 by 2, which is 0.42. Since this is in meter, this is also in meter. Another most important term that we use in every formula is obliquity ratio. Small n, which is nothing but length of connecting rod small l by length of the crank small r. So L is given as 2 meter by 0.42. This will be equal to 4.76. It will not have any units. Since in the question the mass of reciprocating part and mass of connecting rod is mentioned, we have to find M1 and M2 that should be placed at the small end and the big end of the connecting rod respectively. So we have to find M1 and M2 such that MC is M1 plus M2 and that M1 and M2 must be found from these relations. Since the length of connecting rod is given and also the location of G from C is also given, that is L3, which we have noted down as L3 is equal to 0.9 meter. It is given the center of gravity of connecting rod is 0.9 from crank pin. So since we know L and L3, we can find L1 because L is equal to L1 plus L3. So we know all the terms in this. So we can find M1 and M2 from these relations. So it is also important that we draw the mechanism, show all the dimensions and all the forces that are existing in order to solve the problem. Because whenever we are saying L is something, small l is this and theta is this, the examiner must know what L you have chosen. So the L is here, the theta is here, omega is here. So this Pictorial representation of mechanism helps the examiner understand that you are doing things correctly, and also from this figure we can do all the calculations that are required. So from the figure it is clear that the length of connecting rod, which is taken as L, given 2 meter, and it is also given that G from the crank pin C is at 0.9 meter, which we have taken to be L3. So we know that L is equal to L1 plus L3. So from figure we know length of connecting rod is equal to distance of M1 weight to center of gravity along the connecting rod, and the distance of M2 weight, which is acting here, to G along the connecting rod. So since L is given as 2 meter, L1 is not given, L3 is given as 0.9, we know that L1 is equal to 2 minus 0.9, which is nothing but 1.1 meter. So L1 is obtained by us. We know that the mass placed at small end center is M1. This can be given as MC L3 by L1 plus L3. So this is nothing but MC is given as 250 kg. So it is 250 into L3 is 0.9 divided by L1 plus L3 is nothing but L, which is 2 meter. So it is L1 plus L3, which is 0.9. So this is nothing but 250 into 0.9 by 2, which will be equal to 112.5 kg, because MC is given as 250 kilograms. So this will be also in kilograms. Similarly, the mass that is placed at the big end center, which is M2, will be equal to MCL1 by L1 plus L3. This is nothing but again 250 into L1 is 1.1 divided by 1.1 plus 0.9. 250 into 1.1 by 2. This will be equal to 137.5 kg. So this is M1, this is M2. So since we have calculated the masses at small end and big end center, that is a gudgeon pin and at crank pin, we have to find forces. So here FP, because this is turning from, this is at 45 from IDC, so this is power stroke. So the piston will be moving rightward. So the inertia force will be leftward. So we have to find all these forces so that we can find the total torque, because the question is to find the torque on the crankshaft due to all the moving parts, piston, connecting rod, crank, all of these are moving parts only. So we have to find these forces, then we have to find the torque. So in the previous video of doing the dynamic force analysis using analytical method, we have found the total torque T as a summation of the torque exerted on crankshaft due to inertia of the piston, which is Fi, inertia of piston, and the torque exerted on crankshaft due to correction couple TC is given so as to make the non-dynamically equivalent system to dynamically equivalent system. And the third torque is the torque exerted on crankshaft due to mass that is there at the big end center, which is mass is M2. So summing all these three torques will give the total torque that is exerted on the crankshaft due to effect of all the moving parts inertia. If you haven't watched the previous video, the link is given in the description, or you can check with the I link here. Click on this and you can learn from that video. The question here is to find the total torque that is exerted on crankshaft. Total torque on crankshaft due to inertia of all the parts. This is T. Nothing but T1 plus T2 plus T3. We know that T1 is the torque that is exerted on crankshaft due to inertia of the piston. And we know that T1 is equal to Fi, which is the inertia force, Fi into sin theta plus sin 2 theta by 2 root n square minus sin square theta into r. So here we know theta is given as 45 degrees. N we just calculated, n is calculated and found to be 4.76. R is given as, R is not given, we have found R from given length of stroke. R is found as 0.42. So in this, to find T1, we know all of these things. All we need to find is Fi. So from the previous video, we have already derived for expression of Fi. Fi is the equivalent mass into acceleration of the piston, which is nothing but r omega square into cos theta plus cos 2 theta by n. So here we know me is the equivalent mass that is acting at the piston. The equivalent mass is mr and m1 both together, mr plus m1. So me is nothing but mass of reciprocating part plus the mass at the small end of the connecting rod. So this is me. So we know mr, we know m1, r is known, omega is known, theta is known, n is known. So we know all these terms. So we can find Fi by substituting all the values. Me is equal to mr, which is given as 500, plus m1 is 112.5. So this will be 612.5 kg. So this will be 612.5 into R is obtained as 0.42 into omega is 10.47 square into cos 45 plus cos 90 by n is 4.76. So on solving this, we get Fi as 19,940.39 newtons. Now since we know Fi, we know theta, n and r, we can find T1. Substituting Fi and other values, we'll get T1, which is the torque exerted on crankshaft due to inertia of piston. So this is the expression for T1. We know Fi as 19,940.39 multiplied by sin 45 plus sin 90 by 2 root over n is 4.76 and r is 0.42. 4.76 square minus sin square 45 into 0.42. And solving this, we get T1 as Newton meter. So this is torque exerted on crankshaft due to inertia of the piston force. So now we should find T2, which is the torque exerted on crankshaft due to correction couple. Here it is the forces Fc and Fc here that are causing the correction couple. We know that Tc is equal to mc alpha kg1 square minus kg square. mc is given as 250 kg, 250, and we know alpha is omega square sine theta by n into kg1 square by minus kg square. So we know omega, theta and n, but we have to find this kg1 and kg. So in the given question, we were given the mass moment of inertia of the connecting rod. L1, L3 is also known to us. So we have to find kg and kg1. Given Ig is equal to 110 kg meter square, we know that Ig is mass of connecting rod into radius of gyration of the connecting rod square, mk square. So this is known to us, this is known to us. So we can find kg. This is kg is equal to root over Ig by mc. This is nothing but root over 110 by 250. This will be equal to 0.663 meter. So this is kg, this one. Now we also know that kg1 square is equal to L1 L3, or kg1 is equal to root over L1 into L3. L3 is given, from which we have found L1. So this is equal to root over 1.1 into 0.9. So that will be equal to 0.995 meters. So we have found kg and kg1. So we can substitute it here to find TC. On substituting all the values in this TC, we got TC as 2240.96 Newton meter acting in counterclockwise. So these directions are already previously discussed in the last video. Now let us find T2. We know that T2 is equal to TC cos theta by root over n square minus sine square theta. TC is just found, theta is known, n is known, substitute the values and we get T2. This will be equal to 336.634 Newton meter, also acting in counterclockwise direction. So this is T2. Now let us find T3. T3 is the torque exerted on crankshaft due to mass attached at the big end center, which is M2 at point C. We know that T3 is equal to M2G into R cos theta. We have already calculated M2, we know G, we know R, we know theta. Substituting all these values, we get T3. As we have already calculated M2, it is obtained as 137.5 kilogram. We have substituted it here. After calculation, we get it as 400.595 Newton meter. So T3, due to this M2, will be acting in counterclockwise direction. So T3 is also in counterclockwise direction. So the total torque T will be equal to T1 plus T2 plus T3. T1 is obtained as 6811.59 Newton meter, plus T2 is this 336.634, plus T3 is this 400.595 Newton meter. So the summation will be, since all T1, T2, T3 are in the same direction, we have added them up and we get the total as 7548.819 Newton meter acting in the same direction as that of T1, T2, T3. So if you want to come back and see TC, we got a negative value for the used formula. In the previous video, we have discussed that TC is MC alpha kg1 square minus kg square acting in clockwise direction. But on application of this formula, we got a negative value. Negative value means this sense of rotation must be opposite. So that's the reason for this formula it is clockwise. When you get answer in negative value, this is not clockwise. That time this is in anti-clockwise direction. So that's the reason here we have a minus which is not nullified. So we get a minus answer only. So that's the reason we have taken it in counterclockwise. So TC, because of TC there exists T2. So as TC is in counterclockwise direction, we get T2 also in counterclockwise direction. Also in the last video we have discussed that T1, when we are applying effort of piston, the torque due to piston effort Fp will be in counterclockwise. So since Fi is in opposite direction to Fp, when we are considering the torque due to Fi, it will be in counterclockwise direction. So that's the reason why we got all are T1, T2 and T3 in the same direction, that is the counterclockwise direction. Another point to be noted is that here the crank is rotating in clockwise direction, so inertia will be opposing it. So the torque due to inertia forces will be opposite to that. So in this general case that we have considered, all our T1, T2, T3 have come out to be anti-clockwise. So we have summed. In case you get one of them to be acting in opposite direction, then we have to take a negative of that term. This is an arithmetic calculation, also taking into account the direction of the sense of its action, whether it is clockwise or counterclockwise. So here completes our answer.